Okay, so we have here factoring quadratic trinomials of the form x squared plus bx plus c, where c is positive. So let us have an example number 1. Suppose we have here x squared plus 9x plus 14. So the factor of x squared is x. And then since they are both positive, it means the sign here is both positive. So what are the factors of 14? So this is 7 and 2. So let us try for the sum of factors. So what is the sum of the factors? So 7 plus 2, that is 9. So 9 here is correct for the middle term. So 7 and 2 is the possible factors for 14 that gives us a sum of 9. So we have here 7 and 2. So let us have another example. Suppose we have here y squared minus 8y plus 15. So again, the factor of y squared is y and then y. Since this is negative and the last term is positive, this is both negative. So factor ng 15 is negative 3, negative 5. So it gives us positive 15. When we add them, the answer is negative 8. So which is correct also for the middle term here. So negative 3 and negative 5 is possible factors of positive 15. So we write here negative 3 and negative 5. Let us have number 3. So let's say we have here m squared plus 10m plus 16. So again, factor of m squared is m, and since they are both positive, again, the sign here is both positive also. So what is the factor of 16? We can write 4 and 4. So the sum is 8. We have also 8 and 2. So the sum is 10. So since our middle term is 10, so possible factors is 8 and 2. So 8 and then 2. Let us now have another set of factoring. So let's say we have here factoring quadratic trinomial of the form x squared plus bx minus c. So where c is negative. Let's say we have here number 1. So x squared plus x minus 12. So again, factor ng x squared is x, x. So since this is positive and negative, isang negative, isang positive. So what are the possible factors of negative 12? So negative 12, so we can write here negative 4 and positive 3. So it gives us a sum of negative 1. So we can write here also positive 4 and negative 3. It gives us a sum of positive 1. So positive 1 is the middle term for this expression. So the factor of x squared plus x minus 12 is x minus 3 and then x plus 4. Another example. Suppose we have here p squared minus p minus 12. So we have here, again, factor ng p squared, p, since they are both negative, so isang positive, isang negative. So factor ng negative 12, so let's say we have here negative 6 and positive 2, it gives us a sum of negative 4. So another factor is positive 6 and negative 2, it gives us a sum of 4. So still we have no right answer for the middle term. So another factor is 3 and 4. So 3 plus 4, 7. So cannot be. Negative 3 and 4, it gives us a sum of 1. We need negative 1, not a positive 1. So we are just changing the sign of these two numbers. So this will become 3 and negative 4. So it gives us a sum of negative 1. So which is correct for the middle term. So the factor is P plus 3, then P minus 4. So let us have another example. Number 3. Let's say we have here m squared minus 2mn minus 63 n squared. So again, factor of m squared is m and then m. Isang positive, isang negative. So let us have a factor of negative 63 n squared. So that is, let's say we have here 7n and negative 9n. So let us have a linear term. Linear term. So 7n minus 2n. Okay, the sum of term. The sum of term. So we have here 7 minus 9n, that is negative 2n. Okay, that is negative 2n. So if we can write here positive 7n and then negative 9n, let us write the linear term. So we have here negative 9mn and then positive 7mn. So it gives us a result of negative 2mn. So which is correct for the middle term. So the factor is m plus 7n and then m minus 9n. So those are the examples of factoring quadratic trinomial of the form x squared plus bx minus c, where c is negative. So let us have letter C. Factoring quadratic trinomial. Okay, for example, we have here 10m squared plus 28m minus 6. So let us have a possible factor of 10m and negative 6. So let us try have here 5m and then minus 6 and then also 2m plus 1. So let us have a linear term. Linear term. So 5m times 1, so that is 5m. And then negative 6 times 2m, it gives us negative 12m. So what will be the result? That is negative 7m. So this is not correct for the middle term. So let us have another set of factors. Suppose we have here 5m minus 1 and then 2m plus 6. So again, 5m times 6, that is 30m. And then negative 1 times 2m, it gives us negative 2m. So the sum of this, or the difference of this, is 28m. So which is correct now for the middle term? So the factors of 10m squared, 28m minus 6 is 5m minus 1 and 2m plus 6. Another example. Suppose we have here Suppose we have here 6r squared plus 25r minus 9. So let us try factor of 6. That is 2r and then 3r. What about negative 9? So let us have positive 1 and negative 9. Okay, so 2r times negative 9. So it gives us negative 18r. 1 times 3r. The answer is positive 3r. So what is the difference of these two? That is negative 15r. So which is not correct for the middle term. Let us have another factor. So let's say we have here 2r and then 3r and this will come 9 and then negative 1. So 2r times negative 1, that is negative 2 and then r. 9 times 3, that is positive 27r. So what is the difference of these two? So that is positive 25r. So positive 25r is correct for the middle term. So the factor of 6r squared plus 25r minus 9 is 2r plus 9 times 3r minus 1. So let us have another example. Suppose we have here 8p squared plus 46p minus 12. So let us have 8p and then the other side is p. And then what about a factor of negative 12? Let's say we have here positive 4 and this will become negative 3. So 8p times negative 3, that is negative 24p. Then 4 times p, it gives us 4p. So what is the difference between these two? It gives us negative 20p. Is it correct for the middle term? So not yet. So let us have another example. That is 8p and then p again. Let's say negative factor ng negative 12, negative 2, and positive 6. So we have here 8p times 6. That is 48p. And then negative 2 times p, negative 2p. So 48 minus 2, it gives us 46p. So which is now correct for the middle term. So the factors of 8p squared plus 46p minus 12 is 8p minus 2, then p plus 6. Okay, let us have another. Factoring by grouping. Let's say we have here 6x plus xy plus 6m plus ym. So the first two terms have the same common factor, or what we call common factor, which is x. So we can write x here, then 6x divided by x, that is 6. Xy divided by x, the answer is y. The other ones, since they are both positive, we can write here positive. And then the common term between them is m. So we can write m outside the parentheses. So 6m divided by m, the answer is 6. Ym divided by m, the answer is y. So as what you have noticed, 6 plus y inside the parentheses are the same. So the final answer here is x plus m and then 6 plus y. Okay, let us have another example. Suppose we have here 30 minus 5p and then plus 6n minus np. So we have here uh, 30 and negative 5, common monomial factor is 5. We can write 5 here. So 30 divided by 5 is 6. Negative 5p divided by 5 is negative p. Then again, they have here positive. Then common is n. So we can write her n here. Then 6n divided by n, that is n. Negative np divided by n, the answer is negative p. So inside the parenthesis, correction, 6n divided by n is 6. Negative np divided by n is negative p. So they have the same term inside the parenthesis. We can write here 6 minus p, then quantity 5 plus n. Okay, suppose naman we have here 40p, then positive 4py squared minus 8y squared minus 80. So we can combine 40p and minus p. So common monomial factor is 40. Then 40p divided by p, the answer is p. Negative 80 divided by 40, the answer is negative 2. Then plus 4py squared minus 8y squared, common monomial factor is 4y squared. So 4py squared divided by 4py squared divided by 4y squared, the answer is p. So we can write here p. Then negative 8y squared divided by 4y squared. We can cancel them. Negative 8 divided by 4, the answer is negative 2. So again, inside the parentheses, they are the same. So we can write here p minus 2 and then quantity 40 plus 4y squared. And that is the additional techniques in factoring. So we can use those techniques in finding the factor theorem. And we can say factor theorem if they are equal to 0. And I thank you.